Okay, so here we are in 4.5. Chapter 4 is Systems of Equations. Chapter, or I guess 4.5, Section 4.5 is Linear Inequalities or Inequalities. And so here's our first introduction to it. Example 1 and Introduction and 1 Inequality. So let's take a look at linear inequalities and systems of inequalities in two variables and how it kind of compares to linear equalities. So if we've got linear equalities, which we've studied before, linear equalities look like this. We got y equals 2x plus 5, and we got an equal sign. That's the important thing. Solution is basically a line because we got y equals mx plus b. We can graph the from this information. We can grab the slope m, that number in front of the x. We can also grab out the b. B is 5, and that means that our y-intercept is 0, comma 5, because y-intercept happens when x equals 0, and the intercept happens at 0, comma 5. So we can, like I mentioned before, use the y-intercept, then use the slope, and and create a line in the xy plane on our graph. So this results in a line, just the line. Now if we take a look at a linear inequality, a linear inequality, I think my ink kind of disappeared. But the equality, if we're talking about equalities, we've got an equal sign, and we get a line. If we talk about linear inequalities, here's the inequality, meaning we've got an inequality here, one of these symbols, less than, in order left to right, less than, is greater than, is less than or equal to, and the last one is greater than or equal to. In other words, if you're talking about this one, this side is greater than or equal to this side over here, and that's where the inequality comes in. There's no equal sign, there's an inequality. What's our solution? We're going to have a part of the xy coordinate plane. In other words, we're going to have a whole lot of ordered pairs on one side of the line. So one side of the line is going to be shaded in, whereas this is just a line. This is a part of the plane itself. So it's going to be to the left side or the right side or top or bottom of that line. So what do we do first? We first graph the line. So we do all this stuff over here. Start with the y-intercept, get a point, use the slope to get another point, and then you create the line, and then, so that's what graphing the line is. But then over here, we've got to kind of really determine which side to shade. So we've got to find a test point to shade. I'm going to tell you a good test point to shade. And then we just shade the area of an xy plane. So our result then is going to be a shaded area of that xy plane. So let's take a look at what we do. So here's a lot of words. To be honest with you, there's a lot of words here, but it's pretty straightforward. I think I pretty much went over it in the introduction, but here are the more formal steps, I guess. In order to determine which area of the graph should be shaded, which side is the line of the solution, we do the following steps. Number one, graph the line. So we've got to first graph our line. Use our y-intercept to get a point, and then use our slope to get another point, and then we get a line. And then we've got to decide if we use the line or if we use a dashed or dotted line. So if the inequality, remember the inequalities are less than, greater than, less than or equal to, or greater than or equal to. If the inequality includes an equal sign, either less than or equal to, or greater than or equal to, then the line should be solid. And that means that all the points on that line should be included in the solution set. Sorry about that. See if this works. All right. If the inequality does not include an equal sign, either you've got a less than or a greater than, then the line is dotted, and it means that the line itself is not included in your solution set. So you've got to have a dotted or dashed line to show that that line is not part of the solution set. So after you've graphed your line, so graph the line using the y-intercept, using the slope to get another point. We've done that before. Then decide whether we've got whether we include the line or not. If we've got an equal sign in the inequality, then we could include, or in fact we should include, the line. If we don't have that equal sign, don't include the line. And now we've got to decide which side of the line has to be shaded, and basically decide which side of the line should be shaded. And we've got to do that by choosing a test point. I'm going to recommend choosing 0, 0, because that will mean that when we put that 0, 0 into our inequality, the x term will go away, because x times, if x is 0, then 0 times whatever its coefficient will go away. Same thing with the y coefficient. If y is 0, then y times y of 0 times whatever coefficient it is in front of the y term makes that y term go away. And then it makes it easy just to kind of throw away the x term and the y term and then deal with whatever numbers are left. So if we put that test point into our inequality and we come up with a true statement, then 0, 0 should be a part of our shaded area. And the side of the line with the test point is part of the solution. So if the result of our inequality is a true statement, in other words, 5 is less than 10, then we include that point as a test point, or as we include that test point as part of our solution to our inequality. All right, so let's go to an example and see if that makes things clearer. So here's our question. Graph the solution set. All right, so we've got a graph, and we've got to have the solution set. So if we see immediately that we've got an inequality, we know that we've got to have some shading. So we start with this over here, and we can't really graph this right away. 2x plus y is less than or equal to 3. We can't even graph the equal sign. So I'd go over here and I would say 2x plus y less than or equal to 3. We've got to put it into y equals mx plus b format. Our goal is going to be y equals mx plus b, so we can plot the slope m and the b to get our y-intercept. So let's modify this by subtracting 2x here and subtracting 2x here. And I would get y is less than or equal to, because we dropped down that less than or equal to sign, negative 2x plus 3. All right, so now this is in slope-intercept form. Slope-intercept. All right, so my slope m equals negative 2, or negative 2 over 1, or 2 over negative 1, and that's my rise over my run. My b is equal to 3, so therefore my y-intercept is at x equals 0 and positive 3. So that's what I start with. I start with my y-intercept of 0, 3, 0 in the x direction, positive 1, 2, 3 here, and there's my first point. My next point, I use my slope, and all this is graphing. We've done graphing before. So use your y-intercept to get your first point, then use your slope to get your next point. Slope is negative 2, so it should be going like this. Should be forward in the x and down in the y. So we use our slope of negative 2 over rise, negative 2 over rise, and 1 over run. We can also use our slope of positive 2 rise and negative 1 run, and sure enough, there's our 3 points that make a line. They look collinear, so that's good. And now we determine whether we include the line or not. Because again, this is an inequality. It's going to be shaded on one side or shaded on the other. And we got to say, because this has an equal sign here, it does include the line, so that should be a solid line. So there's our first step. We've graphed our line. We determined that it's got an equal sign, so we include the line. Now we use our test point. We say, all right, well, what's my test point? My test point is going to be this one here. So now we say which side of the line is shaded. I'm going to use that point as my test point. And I'm going to start here and I'm going to say, all right, 2x plus y less than or equal to 3. If I include 0, 0 here, because that's my test point, 0, 0. 0 times 2, or 2 times 0 is 0. There's 0. Plus y is 0, is less than or equal to 3, and I'll put a question mark over it. And 0 is 0 less than 3, less than or equal to 3? It is, so that makes sense. 0 less than or equal to 3? Yes. So this side should be shaded. So my recommendation is to put shading like this and say, you know what, my shading should be like this, should be on this side of the line, because later on when we get systems of equations, it'll be a lot clearer to see just these arrows as that's my shading side. So there's our solution set. This line included in the shading and all this side shaded as well. So there's our solution set. So it kind of begs the question as well down here. What if we graphed, here's my question, what if we graphed 2x plus y is less than 3? Because here we graph 2x plus y is less than or equal to 3. So the only difference is less than or equal to 3 or less than 3. The only difference is this has a less than sign, this has a less than or equal to sign. Up here, we use the line. Down here, it would be a dashed or dotted line. So it'd be something like that. The shading would still be the same. So that would be the artist representation of what the solution should be. It'd be the same blue line here, same intercept, same points, but it would just be dashed, and then you'd use, test, I guess, the test point, and you'd determine that this side would be the shaded line, or shaded side also. So there you go, first example.